So next presentation is an introduction to the poster session presenters. Professor Nakajo explains the poster submissions. 次はポスターセッション発表者紹介です。ご講演者は、東京農工大学知能情報システム工学専攻教授の中条様です。ではお願いします。
Okay. 出ますか。あれこっちには出てますけども。あ、来ました来ました。Okay. Okay, good morning. I'm Hironori Nakajo from Tokyo University of Agriculture and Technology. So today I will introduce a poster session. And here is a list of submission, but maybe not all will be presented at the poster area. So this time, some nice poster presentation will be given to you. First, I will give a time for presenters to present their poster in each in a short time, around 5 minutes. So I will call the name. Please come here and just talk. If you want to show your slide, I will switch my PC to yours. Okay. First is Mr. Yang Liu here.
すみません、学生さん、前の方に来てスタンバっててもらえますかね。時間もったいないんで。
Okay, so please come here, around here, this table. Okay, please give your talk.
So hello, I'm Yang Liu. I'm from PLCT Lab, and today I'll have a poster for dynamic rule for RISC-V. So dynamic rule is a code manipulation system, and it supports AX64 and x86. So we ported it to RISC-V, and we have a poster showing the implementation details and the RISC-V porting progress. It has a core module, so it does the code manipulation, does all the hard work for code manipulation, and then it exports API for every client. So you can write some clients with a fairly small amount of code and do any analysis you want, like instrumentation, and so you can, for example, you can with a dozen of code, you can count the program instruction, how a program runs, how many instructions a program uses for its all running process, and you can do something like the memory tracing and stuff like that. So if you want to know more details, you can visit the poster corner. Our poster is at P10. Thank you.
Okay, next presenter, Yang Liu, Mr. Yang Liu. Please come here.
Thank you, everyone. Our presentation is a bit radical. We are doubting if vector extension is right for RISC-V. That's a that's a question we want to maybe answer. As a result, we think that for RV32 and for some low-end application processor, the vector design is completely a failure. And for some larger designs, especially like something with Cortex A53 or A72 or something higher, we think RVV has its maybe advantage over at least SVE or sometimes AVX and AVX512. And that makes us think of maybe building an RVV supercomputer based on the RVV designs here. And for those VLANs longer than 512, there's multiple designs in a vector coprocessor form. And we think that, at least according to previous papers, like the Fugaku's maybe previous researchers, current vector coprocessors might not be the best maybe approach from our perspective. That's the hardware part. The software part is largely ruined from two parts. First is that Anders has, from our perspective, done something very wrong with packed SIMD and making it impossible to reuse the whole P extension. We are extremely maybe unhappy with that. Also, the Sci-5 ruined the intrinsic by adding prefix maybe without any reasons to break the existing code's backward compatibility. Actually, personally, I am maybe undergoing these maybe transitions with extremely difficulty. But after all, since RVV has its maybe sweet point, we hope that RVV can work in their sweet point, but we also think that there should be some alternative methods, alternative maybe SIMD or predication SIMD to vector processor, and that it is a low-cost one, but also maybe useful one. And in the software stack part, another part is that for children, the current LVM has undergoing difficult and disastrous, I can say, disastrous RVV auto-vectorization porting part because of lots of difficulties. We have mentioned most of them in the poster, and if you have more interests, I have made a supplementary material for 12 pages, and the more details will be available in that. So thank you for hearing, and welcome to see my maybe poster in the poster corner. Thank you very much.
Okay, next, Mr. Masato Isobe.
Hello, I will talk about triple modular redundant RISC-V processor on a Cyclone FPGA. So research background, so in decommissioning of Fukushima Daiichi power plant, because of hard radiation environment, using robots, if we use robots, permanent error occurs in integrated circuit by radiation. For example, space-grade processor, processor Razzo Nanagomal. So if we use this processor in decommissioning, so it will be broken only by 10 hours. So we will propose the new the processor by using triple modular redundant architecture. So in poster session, I will show about the construction of TMR RISC-V processor and the implementation results. So please come in. So thank you for listening.
Thank you. And next, Mr. Norimasa Takana.
Hello everyone, I am Norimasa Takana, a student at the University of Tsukuba. Our title is Development of a System for Easy Utilization of RISC-V Extension using Hypervisor Technology. As you know, in RISC-V module specification known as extensions are being formulated one after another. However, the hardware implementation has not progressed as expected, leaving many extensions unused and in a state of limbo. We will produce RISC-V extension in module on hypervisor developers that can be managed in software. Any question in welcome. Thank you.
Okay, so next, Du Wen Bing Kieu. Are you here? No? Oh, okay.
So hello everyone, my name is Hironori Bình. So I come from University of Electrical Communication. So come to the RISC-V day today. I pick up the topic poster with the hardware software co-design of thread-enabled RISC-V space system. So in this work we implement a multi-core system that allow efficiently for the thread multi-thread execution with different level of cache and optimize data flow. So we in this work we would like to solve the cache firstly the data flow issues in the multi-core cache system and promote the near cache processing to reduce the delay and power consumption of the memory access in the multi-core system. So if you are interested with our topic, so please come to our poster and I will explain on your questions. So thank you.
Okay, next, Kai Dui Wang.
Hello, good morning. So my name is Yui. I'm from the University of Electrical Communication. So for today, I bring my work is the implementation of RISC-V SoC that I also integrate lightweight cryptography algorithm to enhance the security. And we did some measurement in 180 nanometer technology. So if you have any interest or question, so please come to our poster. Thank you very much.
Are there any other posters? No. Oh, okay. Did I miss your poster? Oh, sorry. I'm very sorry.
Hi, I'm Yin Minggu, and the title is Linux Capable RISC-V SoC with OpenXA7 for educational purposes. So we wrote a 32-bit very simple RISC-V processor, and writing in pure Verilog, and like it can run like both like real Linux and no-MMU Linux. And as far as I know, it's the first time that 32-bit no-MMU Linux was supported by Linux. And I'll also introduce the OpenXA7, which is a newly emerged open source FPGA toolchains So previously, if we want to do FPGA development, then we need a very heavy toolchain, like ISE or like Cortex or Vivado. But now this is being changed, and there are some people like reverse engineering the bitstream format of the Xilinx and like Lattice or maybe Govin devices. And now like we can use a pure free and open source toolchain to do the FPGA developments. So like if you're interested in like doing FPGA things like without using those proprietary toolchains, welcome to my poster, and I will introduce about the recent status of those newly emerged open source toolchains. Thank you very much.
Thank you. Okay, so I have prepared. We have prepared the voting system. Please vote the most excellent poster from the following Google form. Left one for Japanese, right one is for English version. So please vote your favorite poster presentation. And please stay here because you will get a lunchbox and a green tea each. So we have prepared 3 kinds of lunchbox. One is sandwich, and 2 Japanese rice bowl. 2 kinds. One is traditional triangle one, and the other is I don't know how to say inarizushi. Please tell me how to say in English. Now, please stay here. We will deliver each. And if you will get your not favorite one, you can change at the door. Okay, so that was the presentation, process presentation.
Okay, thank you. So,